Hello, my dear ISRO aspirants. I am here going to discuss about ISRO questions, previous year questions from the production technology. Myself, Madhushekar, faculty at ACE Online and ACE Engineering Academy from last 9 years. I teach material science, production technology, especially for GATE and SC aspirants. Now, for ISRO exam, if you go through the syllabus, for ISRO exam, if you go through the syllabus, especially from the production technology, the syllabus is like welding, casting, metal forming, sheet metal operation, metal cutting, machining, advanced machining methods, non-traditional machining methods, metrology, and also sometimes they will ask you jigs and fixers. Okay, but out of these, if you observe carefully, this previous year questions from last 10 years questions, if you take, the most weightage topics here it is metal cutting is one of the most weightage topic, metal forming is one of the most weightage topic, casting is one of the most weightage topic, and metrology. These are the most weightage topics. The least weightage I'll give you for advanced machining methods. From last 20 years, if you see, only 2 questions they asked. 10 years you can take 3 questions, 2 to 3 questions they asked from the advanced machining methods from last 10 years. So rarely they will ask you questions. So mostly they will focus on metal cutting, metal forming, sheet metal operation, metrology, casting, right? In this 1 hour session, I will explain the syllabus, the weightage analysis, and I'll select some important topics and some important expected questions I'll explain. Now, you can see this is the syllabus and weightage. Okay. Now, next is if you see the weightage, especially from the production, you can see this is the production. In previous, I explained the material science. Now, here I am going to explain production. The production weightage in 2006 is very low, 2 questions only. But if you observe carefully, it is keep on increasing. In 2010, 11 questions, 11 also 11 questions, and if you observe carefully, in 2015, 17 questions they asked, right? And recently in 2020, 25, you can see 10 questions, 11 questions they asked. So that's why what I am saying, the average weightage from production technology, weightage from production technology is 10 questions. Average weightage I am giving. 10 questions they will ask you from the production technology. So, if you cover all these topics, basic fundamentals I am saying, if you cover the basic fundamentals of all these topics, you will get the 10 questions easily. They are very easy, basic fundamental questions they will ask you. The student who is having a basic fundamentals on all these topics, they will get easily. Right? Now we will see the questions from this production. I can't cover all the questions from all the topics. I selected some questions like I am going to discuss in this 1 hour session, metal forming, sheet metal, casting, metal cutting, Mech questions I will discuss, and also some of the questions from the welding also I will discuss. Because of time constraint, you can avail these questions from our AS Academy book. We are also giving the books, you can purchase, you go through the questions also. Now, see, first of all, let us come to the metal forming. See, from the metal forming, what type of questions they'll ask, see here. The question here it is, which of the following processes would produce strongest component? See here, all are, remember, metal forming operations. Rolling is a metal forming, extrusion is a metal forming, right? Rolling and forging. But out of all these things, if you consider, the forging will give you high strength because the grain reorientation takes place more in the forging, right? So because of that, the strongest component you can make out of all these processes. Okay, no? D is the correct answer. Simple question. Next, spinning operation is carried out on. See, actually spinning operation is used to make a cup shaped components like missile cones. You can take the missile cones like these cones you can make by using the spinning operation. Utensils also you can make by using spinning operation by generating plastic deformation. Here we are using a lathe machine to make a cup shaped components, conical shaped components. We are using lathe machine in the spinning operation. So remember, spinning is a metal forming or a sheet metal operation. We are deforming the material plastically. Remember, we are not cutting the metal, but with the help of lathe machine spindles, okay, and tailstock, by supporting that, we are bending the material into a required shape. So C is the correct answer. Now, ring rolling is used to. See, ring rolling is one type of a rolling operation. In ring rolling, suppose let us consider this is a ring of large thickness. Let us consider this is the thickness of a ring. It has large thickness like this. So from this you can make a large size of a ring with the thickness is very, very small. This we call it as a ring rolling. By using rolling operations we can make. So to decrease the thickness and increase the diameter. So this is the correct answer for this ring rolling question. Simple. Now, in the metal forming process, the stresses encountered are, remember, the metal forming operation is performed. Remember, the metal forming operations are performed between the yield point to the ultimate point. So within this region only the residual stresses are induced in the body, so that the stresses encountered greater than the yield strength and less than the ultimate strength. Greater than the yield strength and less than the ultimate strength. So A is the correct answer for this question. Next question. In drop forging, the forging is done by, see, the forging operations are like you can say two types based on the type of load applied: press forging and drop hammer forging. In press forging, the load is applied gradually, but in case of drop hammer forging, force or load is applied suddenly. Sudden impact load is applied, right? So now you can see the options here. Dropping the workpiece at a high velocity, it is absolutely wrong. We are not dropping the workpiece. Second, dropping the hammer at high velocity, not correct. Dropping the die with hammer at high velocity, yes, bottom die is fixed. We are keeping a workpiece on that, and the top die we are lifting up to certain height and then we are releasing. The top die is having certain weight, hammer weight. So C is the correct answer for this question. C is the correct answer for this question. Next, stretch forming is a process in which, see, remember, stretch forming here is what, suppose this is a die, let us consider. So this is a workpiece material, a sheet material. So we are applying the tensile stresses on a body, stretching, tensile stresses on a body. So all deformations occur in the direction of stretch. Second, all forces are applied in the direction of stretch. Advantages is taken of plastic state indicated due to stretch. So here, in a stretch forming operation, we are applying the force in this direction. Tensile stresses we are generating. tensile forces. So here material will deform plastically. So plastic deformation will take place. So that we can say C is the correct option for this question. C is the correct option for this question, right? Now, which of the following process induce more stresses in the metal? Which of the following process induce more stresses, residual stresses in the metal, like hot rolling, forging, swagging, turning? Swagging is also a type of forging operation, but in this case more stresses are induced because in swagging operation, if this is a workpiece material, there are 4 dies, they are rotating and applying compressive loads on this workpiece material. Like that, they are rotating like this and applying pressure, applying compressive load. That's why more stresses are induced in the body. So C is the correct answer for this question. Okay, na? Next, list 1 and list 2 we'll see. In list 1, they are given cold rolling, hardness, impact load, wide drawing. In list 2, indentation, ductility, malleability, resilience. Now, you can say cold rolling. If you want to perform the rolling operation, rolling is for what purpose? To reduce the sheet thickness. So malleability is required. So let us consider rolling, malleability is required. Then second one, hardness. It is the ability of material that can resist indentation. So hardness is first one. Now impact loads is nothing but ability to resist that energy, absorb energy. You can say strictly speaking, they should give toughness here instead of resilience. Toughness, then it is the exact correct word. Okay, no problem, given. So impact load, you can say resilience. Then wide drawing require ductility. Wide drawing require ductility. So P is 3. So A is eliminated, C is eliminated. Next Q is hardness, indentation. So Q is 1, so B, D correct. Impact load 4, so impact load 4, wide drawing is 2, so B is the correct answer for this question. B is the correct answer for this question, simple question. Now, mass production of seamless tubes is by the process of. See, seamless tubes are produced by tube piercing operation. Tube piercing, otherwise roll piercing. Tube piercing is also nothing but rolling operation. Now in this case, suppose this is one roller, top roller, this is a bottom roller, okay. Now we are keeping a mandrel here. Let us consider this is a mandrel. This is a mandrel supporting member. Now if this is a tube, if I want to make a tube here, let us consider the workpiece material is going to deform like this. Workpiece material is going to deform like this, so that it is going to form like this. Like this. So like that you can make the tubes, continuous tubes you can make. So that is called tube piercing. Tube piercing, that is a rolling operation actually. Tube piercing is a rolling operation, remember. Tube piercing is a rolling operation. Next question. The maximum value of reduction in rolling process. See, maximum value of reduction, how will you get actually? Delta H max. So remember, delta H max they are asking. Maximum value of reduction. See, general formula, delta H is equal to, okay, D into 1 minus cos alpha. Delta H is equal to D into 1 minus cos alpha, right? D into 1 minus cos alpha. So delta H is equal to mu square R. Delta H is equal to mu square R. So maximum value of reduction in rolling, actually delta H is equal to mu square R. But in this case, it is not given any clarity regarding this, okay. So you can also take, let us consider tan alpha is equal to tan beta. In that case, maximum value of reduction is possible. Tan beta equal to mu under root delta H max by R, under root delta H max by R, right? So, right, see, general question, generally the formula of reduction is delta H is equal to D into 1 minus cos alpha. That is the one. If you want to get maximum reduction in thickness, that is delta H is equal to mu square R. But in this question, both are not matching. If you see the options, either this is not there, maximum value of reduction they should give mu square R, not there. Second, at least is this formula is there, delta H equal to D into 1 minus cos alpha, even this is also not there. D into 1 minus sin alpha is there, but D into 1 minus cos alpha is not there. See, so that what I am saying from this, I think it is maximum value of reduction per one roller. Let us consider, I will tell you, listen carefully, I will tell you the clarity here. Suppose this is the workpiece material, okay, this is the workpiece material. Now this is the actual reduction from one roller, for one roller, this is, okay, delta H by 2, this is another delta H by 2. So I think they are asking that one. So if delta H is equal to D into 1 minus cos alpha, then delta H by 2 is equal to D by 2 into 1 minus cos alpha. Otherwise, this is the only one way so that I can say this is the correct answer for this question. Even they are also given in the key, this is the correct one. This is per roller actually. They should give, otherwise this is a vague question. This is not exactly the correct actually. Okay, don't worry regarding this question. Next question. Margin wear in drill is due to. See, in drilling operation, especially margin wear takes place due to the, okay, due to the abrasion. Due to the abrasion it will takes place because of wear and tear, because of two mating parts, they are rubbing one over the other, abrasion wear takes place, that we call it as a margin wear. Now, in a single pass rolling operation, the thickness of a 100 mm wide plate, so this is the width they are given, W is equal to 100 mm, is reduced from 20 mm to 50 mm. So H naught equal to 20 mm, H1 is equal to 15 mm. The roll radius is 125 mm. So roll radius is given 125 mm. Right, rotational speed is given 8 rpm, rotational speed, average flow stress is given 400 megapascal. Lengthy question actually, this question they should not ask, because 1 mark, 1 minute, how will you solve the question? You know, first of all, rolling force is equal to 2 by root 3 y bar f into projected area L into W. So L is the length of the deformation zone under root R into delta H. So R is equal to 125 into delta H is 20 minus 15, 5. So I'll get 25 mm. Now, okay, now power, how will you calculate power? Total power 2 into rolling force into, okay, perpendicular distance. 2 rollers we should take, right? Perpendicular distance, that is L by 2 into omega. This is power per one roller, like that we should take two rollers. Now, Fr into L into omega, that is 2 pi n by 60. 2 pi n by 60. L into W also I forgot here. W, omega into L into W also we should take. Okay, Fr you will get W, right? No need of W. Okay, now listen. Fr is what? 2 by root 3 into 400 into L 25 into omega 100. into L by 2, 25 by 2 into omega 2 pi 8 by 60. You just solve this question. By solving this question, you will get the answer easily. In terms of pi, you can solve this question. This one cancel. Right? Now, you can take 25 into 25. Actually, we should take 10 power minus 3 here. Leave that minus 3 in terms of kilowatts we will take, because this is in mm. Minus 3 should take, kilowatts we should take. Okay, na? Now, 25 into 25, 125. Otherwise, let us consider 25 into 8 you take. 25 into 4, 100. 25 into 8, 200. 200 into 25. 200 into 25. How much? 25 2s are 500. Approximately you can take. 5 4s are 20. 20 into 2, 40. 40 approximately I am taking 40 pi by root 3 into 60 you take. Root 3 into 60 you take. So approximately you will get the answer, nearest answer 12.5 by 3 should get. Okay, nearest answer by solving these techniques. Maybe it takes time actually, but the procedure is same. Rolling force 2 by root 3 y bar f L into W, and if you want to calculate power, 2 multiply with the 2 rollers, this is for 1 roller, into perpendicular distance L by 2 into omega, omega is 2 pi n by 60. So by solving this, approximately we will get 12.5 pi by 3 on an average, but it's very difficult to solve this question in the ISRO. 1 minute it is impossible to solve. Actually this is for gate 2 mark question it is actually. Okay, na? Now the questions from the sheet metal operations, you can see, with a punch for which maximum crushing stress is 4 times the maximum shearing stress. So remember, maximum crushing stress is 4 times the maximum shear stress of the plate. The biggest hole that can be punched in the plate would be diameter equal to, remember, the force, compressive stress is equal to punching force divided by pi by 4 into diameter square. Okay. Now punching force is equal to pi d t tau u by pi by 4 into d square. This one cancel, this one cancel, 4t tau u by d. Now you take d is this side common, 4t tau u by sigma c. So sigma c is equal to 4 times of tau u. So that this one cancel, d is equal to sheet thickness you will get, plate thickness. So C is the correct answer for this question. Simple question. Understand? Very basic standard question this is. Now the force required to punch a 25 mm hole in a mild steel plate of 10 mm thick when ultimate shear stress of the plate is 500 Newton per mm square. So punch force is equal to pi dt into tau u, pi into 25 hole into 10 into 500. Use calculator. 250 into 5, 125. 125 into 3. 125 into 3, approximately 393. Simple. Without using calculator, you can able to solve this question. Very simple question. Next, the initial blank diameter required to form a cylindrical cup, outside diameter d, total height h, having a corner radius r, is obtained by using the formula. Now listen, this is a blank, cylindrical blank of diameter capital D, let us assume. From this cylindrical blank, I am going to make a cup like this. This cup height is h, this outer diameter of this cup is d, right. So what is the formula? What is the general formula? One side surface area of a blank is equal to outside surface area of cup. one side surface area of blank is pi by 4 d square is equal to outside surface area pi by 4 d square plus pi dh. Pi dh is the perimeter. Now d square is equal to d square plus 4 dh. So d is equal to under root d square plus 4 dh. Now if I take the corner radius RC, you can take minus RC by 2. Out of these 4 options, the first option is the correct option for this question. Simple question. It's a very simple question for your exam. Next, spring back in a sheet metal depends on spring back in a sheet metal. Suppose after deforming the material, if we release the load, some amount of material regains back. That is because that depends on the modulus of elasticity. Okay, that depends on modulus of elasticity. If let us consider the material, if the material is like this, suppose I applied the load up to here. If I remove the load, material follow like this much amount of material bounce back. This much amount of material bounce back, so it depends on the modulus of elasticity. Next, corrosion in aluminum plate occurs when it is connected with the mild steel plate and exposed to the same environment. This phenomena, that is actually galvanic corrosion. See, galvanic corrosion occur if two dissimilar metals are joined. Suppose steel and aluminum, if it is joined, the aluminum is more anodic in nature, so aluminum will corrode. So that we call it as a galvanic corrosion. Next, in a sheet metal of 3 mm thickness, a hole of 7 mm diameter needs to be punched. Yield strength in the tension is 120 megapascal and its ultimate shear strength is 100 megapascal. The force required, very simple, pi d t tau u. Pi e, diameter is 7, thickness is 3 into 100. 7 3s are 21, 21 3s are 60 approximately. So you will get 6.6 kilonewton. Pi is 3.14 into 7 into 3 into 100. So approximately you will get C is the correct answer. Simple question. Pi dt tau u you will get in newtons. Simple question. This is in megapascal, right? Right. Now, the state of stress during deep drawing forming operation. See, in deep drawing forming operation, let us consider, if I consider a cup, okay, the bottom portion, okay, without like any blank holding force, no stress will generate. If there is any blank holding force, there is a tension. And in the side walls, if I take, only tension will generate either without blank holding force or with blank holding force. Then flange portion without blank holding force, tension and compression will generate. With blank holding force, only tension will generate. Remember that, the mechanism. So out of these 4 options, you can see the correct option in the flange of the blank, biaxial tension and compression, and in the wall, simple uniaxial tension. So remember, in a flange portion, tension and compression will generate because foldings generated without blank holding force. If we apply the force, foldings generated, that's why tension and compression. But at the wall section, uniaxial tension will generate, so that C is the correct answer for this question. Now, some of the questions I am going to explain from the casting process. Now see here, shrinkage allowance is made by. See, shrinkage allowance is made by, you can see the 4 options. First option is adding to external and internal dimensions. Second option, subtracting from external and internal dimensions. Third option, subtracting from external dimensions and adding to the internal dimensions. Fourth option, adding to the external dimensions and subtracting from the internal dimensions. See, in case of casting process, shrinkage allowances, if we take, we should add either external dimensions or internal dimensions. Generally, Some of you people think that for internal dimensions we should neglect, we should subtract like that. No, the material is going to shrink even internal dimensions also. That's why we should add both external and internal dimensions. A is the correct option. Next question. Investment casting is used for. See, by using investment casting process, you can make the complex shapes. That is the main advantage of investment casting process. Now, out of these 4 statements, you can see shapes which are made by difficulty using complex patterns in sand casting. B. Mass production, shapes which are very complex and intricate and cannot be cast by any other method. This is nothing like investment casting. So, C is the correct answer. So, investment casting, difficult shapes we can make. See the shape, very difficult, you can make by using investment casting. That is the one. Now, fluidity in casting, cast iron, this is casting of cast iron operation, is greatly influenced by. See, remember, fluidity depends on so many parameters like surface tension, like you can say viscosity, pouring temperature, right? So, at what pouring temperature you are pouring, it also depends on that. So, if we increase that pouring temperature, the fluidity will increase. If the pouring temperature is less, fluidity is going to decrease here. So, melting temperature of molten metal, it doesn't matter. Pouring temperature of molten metal, this is the correct one. Finishing of the mold, it influences but not completely, only at the surface regions it influences. Carbon content in the molten metal, generally if we take low carbon steels and high carbon steels have high castability because of high carbon content, it influences. But here that compared to this carbon content point, because they did not mention a particular steel, a cast iron is given like that, Ci is given. So, cast iron, right? For cast iron more or less same carbon percentage is there, 2 to 4. That's why B is the most appropriate answer for this question, pouring temperature of molten metal. Next, draft on pattern for casting is provided for. See, generally you can see this diagram, okay? This is a, remember, pattern. This is a pattern. We are going to make a mold by using a pattern. Suppose if we make like this, if we try to make the mold or a pattern like this, during this removal process, after making mold by using a pattern, if we try to remove, there is a problem, wear and tear, rubbing, so that surface roughness, it is very difficult to remove. That's why we are creating a draft. We are increasing the clearance slightly for easy removal of a mold pattern, right? So, that's why draft is provided. It's a tapper to facilitate removal from the mold. Okay, na? C is the most appropriate answer. Next, the purpose of adding wood floor to the molding sand is to improve. The purpose of adding wood floor to the molding sand is to, see, we are adding wood floor to the molding sand to increase the green strength. Remember, to increase the green strength. So, A is the correct answer for this question. Next, addition of coal dust to the green molding sand is to improve. So, coal dust we are adding to improve surface finish. Coal dust we are adding to improve surface finish. B is the correct answer for this question. Next, slush casting process is used to produce. Remember, slush casting process is also known as a halo casting process, used to make halo sections like statues, toys, bowls, decorative items. Okay, now, so you can say out of these 4 options of the slush casting, halo casting is the correct answer for this question. So, A is the answer. Slush casting process is used to produce halo castings. Halo castings. Next, two castings of the same metal have the same surface area. Okay. Now, one casting is in the form of a sphere and other is in the cube, right? What is the ratio of solidification time for the sphere and for the cube? See, both sphere and cube have same surface area. Surface area of sphere is equal to surface area of cube, right? So, 4 pi r square is equal to 6a square. So, from this r is equal to 6 by 4 pi under root into a. Now, solidification time is directly proportional to surface area to volume ratio whole square, right? So, now here I want solidification time for sphere and solidification time for, remember, solidification time for sphere by solidification time for cube. Solidification time for sphere, solidification time for cube if I take. Now, solidification time, surface area by volume whole square for sphere divided by surface area by volume whole square for cube. Now, you can take surface area 4 pi r square by 4 by 3 pi r cube whole square divided by 6a square by a cube whole square. If we substitute the r values in this equation, you will get the answer 6 by pi approximately, right? This is the one. So, remember, solidification time is directly proportional to surface area by volume whole square. By using this, you will get the answer easily. So, B is the correct answer for this question. Now, misrun is a casting defect which occurs due to, remember, suppose you can see this is a casted component. Here, this defect is a misrun defect. Tell me, out of these 4 options, which option is the most appropriate one? Now, see here, very high pouring temperature of the metal. Second, absorption of gases by liquid metal. Third, insufficient fluidity of molten metal. 4, improper alignment of mold flask. Remember, because of insufficient fluidity of molten metal, it may not reach into this portion. That's why it is formed, a misrun defect is formed. So, remember, insufficient fluidity of molten metal. Next, in continuous casting process, the mold is generally made up of. In continuous casting process, the mold is made by the copper. The mold is made by the copper material. In continuous casting process, the mold is made by the copper material. Right. Now, I am going to discuss some of the questions from the metal cutting and machining. Okay. Now, you can see the machinability depends on. So, what do you mean by machinability? Machinability is nothing but ease of doing machining operation. Suppose if a material, let us say this is aluminum, if it is easy to cut, easy to make into a different shape by cutting, we can say it is a good machinability. Suppose if I take aluminum and steel, aluminum is easily machinable compared to steel. So, aluminum has high machinability. So, this machinability depends on the so many parameters. But out of these parameters, the most appropriate important parameters are like cutting force, the cutting zone temperature, tool life, surface roughness and chip formation. Now, in this, first option is given microstructure, physical and mechanical properties and composition of the workpiece. That is also correct. Suppose if we take a fine grain material, it is more hard, so machining is going to decrease. Mechanical properties you can take, if a metal is having more hardness, high strength, again machining is difficult. Like by adding alloying elements, some metals are becoming hard, so machining will decrease. So it is also, machinability also depends on microstructure, physical and mechanical properties and composition of workpiece material. Machinability also depends on the cutting force, type of chip and tool life, right? But all four are correct actually in this case. So which one you will take? So it's your choice, but out of these, the most appropriate answer I am giving, most weightage answer I am giving is for A. Because if a metal has a coarse grain microstructure, suppose if a metal has less alloy content, it is easy to machine. Less cutting force is required. Tool life will increase. So mostly the depending on the workpiece properties. That's why the most appropriate answer out of all these four I am taking with A. A is the correct answer for this question. Now let us consider second one. What is the correct sequence of the following parameters in order of their maximum to minimum influence on tool life? Maximum to minimum influence on tool life. So feed rate, depth of cut and cutting speed. So very basic, you are familiar about the tool life equation, Vt power n equal to constant, you can say. So cutting speed play a key role, right? So first priority I am going with this. Then second priority is a feed rate. The least priority is depth of cut. So that the most appropriate answer is 3, 1, 2. That means cutting speed, feed rate and depth of cut, the correct sequence. Now, for achieving a specific surface finish in a single point turning, the most important factor to be controlled is, see, the specific surface finish or roughness. The specific surface roughness or roughness formula for turning operation depending on this, okay. The surface roughness, like suppose you can take, let us consider, this is the maximum peak height, you can say H max. So this H max depends on, H max is equal to feed square by 8 into nose radius. So here H max is inversely proportional to the nose radius and directly proportional to the feed rate, or feed, you can say feed rate. So out of these four options, the H max independent of depth of cut, cutting speed and tool rake angle, so that the most appropriate answer for this question is C. The most appropriate answer for this question is C. Next, a cutting tool having a tool signature as 10, 9, 6, 6, 8, 8, 2 will have a side rake angle. This is actually American Standards Association system, you can say. So as per this American Standard Association system, the second one, this second one represent a side rake angle. Side rake angle. So here 9 degrees is the correct answer. So second one will give you, from the left side, will give you the side rake angle. First one is back rake angle. Okay, no? As per the ASA system, this is ASA system. Remember, ASA system. The last one, this one will give you nose radius. Okay, no? Next, see, a mild steel block width of 40 mm is being milled using a straight slab cutter of 70 mm diameter with 30 teeth. If the cutter rotates at 40 rpm and depth of cut is 2 mm. What is the value of maximum uncut chip thickness when the table feed is 20 mm per minute? So this question is related to the milling operation. Now you can see some of the formulas important. For example, the milling operation, maximum uncut chip thickness is 2f by nz under root d by d, and average uncut chip thickness f by nz under root d by d, and peak to valley surface roughness, that is f square by 4d n square z square. Here in this question, they are asking maximum uncut chip thickness. So maximum uncut chip thickness, remember, maximum uncut chip thickness is 2f by n into z into under root d by capital D, right. Here f is a feed. Now you can see block of width 40 mm is being milled using a straight slab cutter of 70 mm diameter. This is capital D, 70 mm. 30 teeths are there, so Z equal to 30 teeths. Cutter rotates at 40 rpm, N equal to 40 rpm. Okay. Depth of cut is given 2 mm, that is small d, depth of cut. What is the value of maximum uncut chip thickness? With a feed of 20 mm per minute. Now we can see 2 into feed is given 20 mm by speed is given 40 rpm. Teeths are 30 under root. Okay. Depth of cut is 2. Diameter is 70. Depth of cut is 2. Diameter is 70. We don't have calculator. Now listen, how to solve this question? It's very simple. You can say it's very simple. So 1 by 30 into, remember 35, root 35, 1 by 35, generally you can assume it as a 36, 1 by 36. So 1 by 6 you can take, right. So that is 1 by 180. But we don't have a calculator, so I'll take approximately 1 by 200. 1 by 200, you will get 0 point something something 4. 4 you will get. But it should be greater than 4 because it is 180 only. So nearest answers you go through that. Nearest answers you go through that. But here all the answers are there. Nearly that. Sir, it's not 1 by 4, it's 1 by 5 they should get. 1 by 5 approximately. So that D is the most appropriate answer for this question. D is the most appropriate answer for this question. 1 by 2 is 1 by 2 is 0.5 you can say. So 0.00563 is the correct answer for this question. Simple question, right. Now next question you can take. Diamond cutting tools are not recommended for machining of ferrous materials due to. Why diamond cutters we are not using for ferrous metals, iron metals? See, diamond is a very high hard material compared to ferrous. Okay. The main reason is in iron carbon is there, in diamond is also made up of carbon. There is a chances of diffusion of these carbon atoms. So chemical affinity of tool material with iron. So there is a chances to a formation of carbon from the diamond or from the iron with each other. So chemical affinity of a tool material with the iron. So that is the main reason. So B is the correct answer for this question. Now projection welding. Remember, projection welding is a continuous welding operation. Okay, na? Projection welding is a continuous welding operation, but here multi spots we are using. It's not like a like suppose you can say here it is one spot, here it is one spot, like that. We are not doing the welding everywhere here like that. So you can say it's a multi spot welding process. Projection welding is a multi spot welding process. Remember, don't confuse. Okay, now next. Now, resistance spot welding is performed on two plates of 1.5 mm thickness with a 6 mm diameter electrode using 1500 amperes of current. So, current is given 1500 for a time duration of 0.25 seconds. So, T is given 0.25 seconds. Assuming the interface resistance is 0.0001 interface resistance, the heat generated, very simple question, right? Heat generated is equal to, that is Q, that is I square RT. I square RT, simple question. Now I is what? 1500 whole square. Resistance is what? 0.00001. T is what? 0.25. So we don't have a calculator. So in a simple way, I'll go to here 15 square. What is 15 square? Approximately 225, like that. By 4, you can take by 4, if you take you can take 200 by 4, 50 approximately. So the correct answer is 5625. Without using calculator I am doing. Simple calculations, just consider 15 square. 0.25 means 1 by 4 I am taking, 15 square by 1 by 4. Even if you don't have that idea, 15 into 15 by 4. Okay, now, like you can take 4 4s are 16, right? 15 4s are 60 approximately. So this is the answer. Simple calculation you can use. Now, preheating before welding is done. So remember, before going to the original welding, we are doing a preheating. For what purpose we are doing a preheating? To remove any dirt is there, oil is there, grease is there. To remove that one, we are doing a preheating operation, so that burn away oil, grease, etc. from the plate surface. We are going with preheating. Next, which one of the following is a solid state joining process? Remember, the solid state joining process here, that is a friction welding, is a solid state joining process. So C is the most appropriate answer for this question, solid state joining process. Next, below the ductile to brittle transition temperature, the weld joints show. Now listen carefully. Ductile to brittle transition phenomena I'll explain. You can take, okay, let us consider the x-axis represent a temperature, y-axis represent ability to absorb impact energy. X-axis is temperature, y-axis is ability to absorb impact energy. Now, if we consider the graph is like this, right? Especially only the BCC structure metals follow like this phenomena, ductile to brittle transition phenomena, right? BCC structure metals, you can take steel is the best example. Steel metal follow like this. Now there is a transition temperature. This is the transition temperature, ductile to brittle transition temperature. Above this ductile to brittle transition temperature, material is ductile. Below this transition temperature, material is brittle. So if material is a welded material, let us say, if it is a ductile to less than this temperature, metal is more brittle, so it will break easily. So out of these 4 options, below they are asking. Below means less than this temperature metal is brittle. So below this temperature, high ductility is wrong, high toughness is wrong, low toughness is right, ductile fracture is wrong, because metal will not fail by ductile, brittle material, it's like ceramic. So C is the correct answer for this question. Okay, now Now, compressive residual stresses in weld joints. See, in weld joints, the compressive residual stresses are generated due to that crack will propagate easily, increase the cracking tendency. So, B is the most appropriate answer for this question. Okay, compressive residual stresses in the weld joint increases the cracking tendency. So, B is the correct answer. Now, which of the machine tools can be used for boring? Boring operation is nothing but enlarging the hole size. Already existing hole is there. So, we are going to slightly increase the hole size. Like super finishing operation, super finishing of a hole you can say. So that we are not using drilling. Drilling machine we are not using here. Drilling is used to make holes. Drilling machine is used to make holes. So that drilling is not used. So this is not correct, this is not correct, this is not correct. So B is the correct answer. You can use lathe machine, you can use vertical milling machine, you can use horizontal milling machine for boring. Okay na? So drilling is not used. Boring is after drilling we are doing boring. So that's why. So B is the correct answer for this question. Now, internal and external threads can be produced on a tapered surface conveniently by, remember, universal milling machine is used to make internal and external surface. Okay na? Universal milling machine we are using to make internal and external threads. So A is the correct answer for this question. A is the correct answer for this question. Next, which of the following screw thread is adapted for power transmission in one direction? Power transmission in one direction. Now listen carefully. Now listen carefully. Buttress threads we are using for power transmission. Power transmission in one direction. Remember, in one direction we are using this one. AC ME threads we are using in lathe machine. Lathe machine lead screw you can take. Square threads are used for power transmission. Square threads are used for power transmission in both directions. Power transmission in both directions. So you can see here, listen carefully. So adapted for power transmission in one direction is buttress threads. So B is the most appropriate answer for this question. Simple question. Now, a milling cutter having 8 teeth is rotating at 150 rpm. If the feed per tooth is 0.1, the table speed in mm per minute. Remember, table speed in mm per minute we want. Table speed in mm per minute. So you can say, you can take speed, feed, okay, and you can also consider number of teeth, multiplication, okay. Suppose the speed is 150 revolution per minute, feed is 0.1, the cut number of teeth are 8. So you can take 15 8 120. So A is the correct answer for this question. It's very simple question. 120 mm per minute. 120 mm per minute. Right? So these are the some of the questions. Like that, there are so many questions. You just go through the previous year questions from last 10 years. You practice it so that you'll gain lot of knowledge. Sometimes these questions will repeat in the exam paper. So if you want to crack ISRO exam, should go through the previous year gate questions from last 20 years. Okay, remember, I'll give you clarity. Remember, I'll give you clarity here. To crack this exam, okay, you go through gate previous year questions last 20 years. Then go through ESC prelims, technical I am talking, mechanical, last 20 years. Okay, ESC prelims technical questions last 20 years, and ISRO questions, previous year questions, last you can say like some 15 years or 10 years based on the availability. You go through these questions, you practice these questions more than enough, same model it will repeat. It is easy to crack this exam, same model questions it will repeat, only the thing you should understand the question. That's it. Otherwise it's very simple exam, right? So all the best for your exam. Thank you.